Everyone, in today's video I will be solving a problem based on moment area method. So in today's video I'll solve for a cantilever beam. Okay, so in the cantilever beam one side is always fixed and the other side is free. So this type of beam is known as cantilever beam. So in this question, one side is fixed and in the other side a point load is acting. Let this end, let's assume it as A and it as B. So in the moment area method, first of all we have to draw the bending moment diagram. So bending moment diagram for this cantilever beam will be like this, right? So now this is a bending moment diagram, and again we have to draw the BMD by EI diagram. So in the bending moment diagram this will be W into L. Okay, so let it be W, and this is the length of the beam. So here the maximum deflection, the maximum bending will be W into L, and it will be in a negative side. Now we have to draw the BMD by EI diagram. So BMD by EI diagram, it will be same as this BMD diagram, only the difference is this one. Okay, just we have to draw same as BMD diagram. Just what happened, in place of W into L divided by EI, we have to just write divided by EI, and the sign will be negative for this case also. Okay, this one was A and B, this one was also A and B. Now here in the moment area method, what happened, we have to find the slope and the deflection. So now let's find the slope. We can write apply first theorem. So in the first theorem we have to find the slope. For slope, and slope is denoted by this term theta. Okay, so here, as I already told in my previous video also, at the fixed support the slope and deflection will always be 0. Okay, and in the hinge and in the roller support, deflection will be 0. Okay, so this is the important points which we have to remember. Now for finding the slope, here in our case this A end is fixed, so there will be no slope and there will be no deflection, but this end there will be a slope, right? So what happened, we'll do slope at B is denoted by the term theta B minus theta A. Theta A is slope at A point, is equal to area of M by EI diagram. M by EI diagram is nothing but this diagram. Okay, BMD by EI diagram. So now theta B minus theta A. I have to redraw the diagram here. Okay, so now our diagram was like this, right? Like this, and here WL by EI. So now what happened, it was A and it was B. In the A point it was fixed, right? So for the fixed support, slope will always be 0. So here this term will be 0, is equal to, this one was M BMD by EI diagram, or it can be called as M by EI diagram. Now area, to find the area, this is a triangle, right? So what will be the formula for finding the area? That is half into H into L. This is the L. Now here I'll write it half into h into L is equal to, it be theta b. Half into, here h is nothing but WL by into WL by EI into L. So we'll get the value for this one is WL square by 2 EI, and the sign of this one will be negative because it's in the downward direction, right? So it's a negative. So theta b is equal to this one. So this is the formula for a cantilever beam when the point load is acting on that particular beam. Okay, so this is the theta b value. Theta b is nothing but slope at B. Now again we have to find the deflection. So now what we'll write, apply second theorem, and second theorem here, second theorem is used to find the deflection and the first theorem is used to find the slope. Okay, now we'll proceed with the second theorem. So here we need to find the deflection. For, I'll write it down here, for deflection at B. Now see, suppose this was our cantilever beam A and B, and here the load is acting. So our deflection diagram will be like this, right? So our beam will deflect like this. So this is the deflection, and deflection this one can be denoted by this term or it can be denoted by this delta. Okay, so now for here deflection at B, okay, is equal to moment of M by EI diagram at B. Okay, so now how to find a moment? Moment is the area. So M by EI diagram, right? M by EI diagram was like this. Here WL by EI, and it's a L. So it's a in the form of triangle. So it will be area into the distance of CG. So now for this type of beam, here at the center the CG will act, and from this CG distance to the edge of the beam, the length can be determined by 2/3 of L, and from this end to the up to the CG, this length can be determined by 1/3 of the L. These things are very important, which we have to remember. Okay, so now here we can say that it will be area into the distance. Now what is the formula of area? Area is half into L, this L into WL by EI. This is the area formula into the distance. Distance is what it says, moment of EI diagram at B. At B, this is BA. Okay, so from here to here, this CG distance we have to take into 2/3 of L. So now what we'll get, WL square by 2EI into 2/3 of L. So this 2 and this will get cancelled. So what will remain, WL cube upon 3EI, right? And this one will be negative because it's in the downward direction, right? So negative. So delta B is equal to minus WL cube upon 3 by 3EI. So this is the deflection value for B point. Okay, now here most important things which we need to remember is, to find the slope we have to use this formula. Okay, this is the formula for finding the slope. So for finding the slope, there is a, we have to find the area, this area. Okay, area of the M by EI diagram. And for the finding the deflection, we have to remember this formula, that is moment of M by EI diagram. So moment can be determined by the area into the distance, area into the distance. And here the last step is to draw the elastic curve. So now our question was this: cantilever beam where at this end one point load is acting. So our elastic curve diagram will be here. When this load is acting on this beam, what happened? The deflection of the beam will be like this, right? So this will deflect like this, A and B. Now we have to draw a tangent from this end. Okay, a tangent at this point, and this angle is the theta B angle, and this length was L, and this was the theta. Theta is nothing but the deflection. So this is the figure, is the elastic curve. Okay, so here in the moment area method, what we have done is, in case of the cantilever beam, first of all we have to draw the bending moment diagram, and second is to draw a bending moment diagram by EI, and from this BMD by EI diagram we have to find the slope and we have to find the deflection. Okay, so after finding this both, we have to draw the elastic curve diagram. So this is our elastic curve diagram where this is nothing but the deflection of the beam, and this is the slope at B point. Okay, thank you.